take a look at the 11.6 notes. They are proportions and solving rational equations. So in lesson 11.5, we were able to figure out in equations where is the denominator not allowed to equal 0. So we found extraneous solutions. We are going to check for extraneous solutions after we do our problems just to double check. So anytime we have x's in a denominator, we need to make sure that we don't have extraneous solutions. All right. So let's remember some stuff. Proportions. What the heck is a proportion? So a proportion means that two ratios are equal. In other words, what we have is fraction equals a fraction. That's a proportion. Okay, so you'll see me a lot of times draw a fraction bar, put an equal sign, and then draw another fraction bar. Okay, a rational equation or just a rational means a fraction where the top and bottom of the fraction are polynomials. Okay, so that means that x's are not allowed to be in numerators, or not numerators, x's are not allowed to be in exponents, and x's are not allowed to be inside of square roots or anything weird like that. So just normal looking equations. Okay, a percent setup. So we will come back to the percent setup when we finish up with numbers 4 and 5 down below. Okay. Numbers 1, 2, and 3, we are going to solve these proportions for x. Way easier than it looks. What we are going to do is cross multiply. So we take the top of one fraction and multiply it times the bottom of the other fraction. Because what we do is we are trying to undo the fact that this says divide. We want to do multiplying. So if we multiply both sides of this fraction by 4, this 4 will cancel and there will be a 4 up here in the numerator. Then this says divide by 5. We don't want to actually divide by 5, so we multiply both sides by 5. When we do that, this 5 cancels, and then 15 actually multiplies times the 5. Okay. So the fast way to do that kind of multiplication and simplifying is to take literally one numerator, like this x plus 9, and multiply it down here times the denominator, and multiply this numerator times that denominator. Okay, I've color-coded so you can see where everything is headed. All right, I start up here with the 15, and I multiply it down here times the 5. So the 15 times the pink 5, and that is going to equal x plus 9. Go ahead and put any polynomials that are more than one term into parentheses as you write them down. So this x plus 9 multiplies down here times that 4. And I'll put the 4 in the front. Okay, so top left times bottom right, top right times bottom left. Okay, and then I'll switch to purple for everything from here on out. All right, so 15 times 5 is 75 equals, and let's distribute this out. 4 times x is 4x, 4 times 9 is 36. And now we just have a two-step equation. So we all know that we are supposed to subtract 36 from both sides. So 4x, bring down the equals here, and 75 minus 36 is 39. A lot of times these will end up with fractions or decimals. It's fine. Let's divide both sides by 4. And we end up with 9.75 equals x. Okay. We do need to check for extraneous solutions. You need to check for extraneous solutions. So take the denominators, and if there's any x's in them, set them equal to 0. 5 does not have any x's, 4 does not have any x's, so there are no extraneous solutions, which means that 9.75 is an okay answer for x to equal. Problem number 2, color-coded again. I'm going to go ahead and put the two-term parts into parentheses. All right, let's multiply. So the 7 up here gets multiplied times the x plus 7 from the other denominator equals, and the 3 from the first numerator gets multiplied times x minus 4 from the second denominator. All right, looks like distributing time. 7 times x is 7x. 7 times 7 is 49. Equals 3 times x is 3x. 3 times negative 4 is negative 12. Okay, this problem, we have x's on both sides of the equation, so we do need to make sure that all x's get moved to the same side. So let's subtract 3x because it's smaller than 7x, minus 3x, minus 3x. So we have 4x plus 49 equals negative 12. And now we have this two-step equation. So we can, let's see, subtract 49 from both sides. That's not a pretty answer. Negative 61 equals 4x. And when you divide both sides by 4, you get x equals negative 4, looks like 15.25. When we, in lesson 11.5, looked at those denominators and set them equal to 0, or not equal to 0, really, we ended up just kind of getting the opposite number from what was down there. So if x plus 7 cannot equal 0, that means that x is not allowed to equal 7. That's an extraneous solution. Over here, x minus 4 cannot equal 0. So when you add 4 to both sides of that, you get x is not allowed to equal positive 4. So x is not allowed to equal those two numbers, but that's not the answer we got down here at the bottom anyway. So this answer is okay. All right, we got one more of these. Number 3. My little equals there. All right, I'm going to take the orange, x plus 6, multiplied times pink, x minus 4. And then green times blue, x minus 1 times x. The blue does not really need to be in parentheses because it was only one term. All right, we're going to have to distribute on this left one. X times x is x squared. X times negative 4 is negative 4x. 6 times x is 6x. And 6 times negative 4 is negative 24. Right, because you have 2 terms times 2 terms is going to get you 4 terms. Second side, x times x is x squared. X times negative 1 is negative 1x. All right, let's subtract x squared from both sides. Okay, so those guys cross out and those guys cross out. The right side is negative 1x. Looks like we can combine a couple of terms. On the left, negative 4x plus 6x is positive 2x. So 2x minus 24 on the left. We need all x's on the same side. I'm going to subtract 2x from both sides so that we have numbers on one side and x's on the other. So we've got negative 24 equals negative 3x. And then divide both sides by negative 3, and we get 8 equals x. Let's check and see if 8 would make either of these denominators equal 0. 8 minus 4 does not equal 0. If this x turns into an 8, it does not equal 0 either. Right? This would be x is not allowed to equal positive 4. This one, x would not be allowed to equal 0. There's nothing to solve on that one. So that answer, x equals 8, is totally fine. It is okay. All right, we'll do those word problems in the next video.